We have already discussed how Davison and Germers used their experimental setup to prove that electrons can behave as wave. So now we are going to apply electrons in the field of microscopy for practical purposes, and we can see that there's actually some advantages, some significant advantages in using electrons in the field of microscopy compared to the usual light microscopy that we're used to. So for usual light microscope, which we use in the lab, those normal microscope that we use to study chick cells, to study plant cell. For those kind of light microscope, ray of light are bent by reflection or refraction to form an image of the object. So if today you have a light microscope over here, this is a usual microscope that you might see in your lab. What happens is you place your object or your specimen on this stage over here. So what happens is you bring in light from the surrounding through this mirror and reflect it towards the specimen. So the light from the surrounding will pass through a specimen. Then afterwards, you are going to use a system of lens and mirrors to converge the light. So these lights, after they pass through a specimen, they will be directed into in certain ways so that so that the light ray can fall onto the retina of our eyes. So once it fall onto the retina of eyes, our brain will be able to process those kind of information in order to produce a magnified image. Okay, so the specimen was very, very tiny, but you're able to form a magnified image through this light microscope over here. So electron microscope is running on the same principle actually. So for electron microscope, you are using electron beam rather than ray of light. So instead of shining ray of light passing through a specimen, for electron microscope, you are shining electron beam passing through the specimen. And afterwards, because electron beam is not light can be bent by having lenses and mirrors, or you use mirrors and lenses to bend the light in different shape, either to converge it or diverge it. But when we are talking about electron beam, you cannot let electron pass through a lens in order to converge or diverge it. Okay, you can only direct the motion of electrons using the electric field and magnetic field. And this is related to the earlier chapters that we have been learning in this semester. When we talk about having an electric field or a magnetic field, we are able to direct the motion of the electrons when they are in those fields. So for light microscope, we are going to use lens and mirrors to reflect or refract the ray in order to form an image. But for electron microscope, we are going to use electric field and magnetic field to bend the motion of the electrons in order to form an image. Okay, so this is a typical transmission electron microscope, also known as TEM. Okay, so transmission electron microscope looks something like this. The general idea is you have a place where you emit your electron. So electron is coming out from this place over here. Then you pass through the object, which is a specimen over here. So when you pass through the specimen, those electron beams will contain information of the object. Then you're going to pass through one lens, one system of objective lens and one system of projection lens in order to form your image on this piece of sensor over here. Okay, one thing that you might need to be careful about is that this objective lens or this projection lens here, they are not glass lens that we're usually used to. So we call it as lens, but it's actually the place where there's electric field and magnetic field. So we place electric field and magnetic field here to control the direction of the motion of the electrons after it passes through a specimen. And from there, we are directing the electrons to fall onto a detector to form a magnified image. Okay, so it runs on a similar idea to light microscope, but the mechanism behind it is different. Okay, so here I'm going to go through the idea in a bit more detail. So this is an object, of course. Then you have a system to bend your electron beam to form your image. But to make it more, explain in greater detail, what happens is you have electrons emitted from a hot cathode. So this is where you have your thermionic emission that happens. Basically, apply a voltage over here to heat up this filament or this cathode over here. So once it's heated up, you emit electrons, just similar like the Davison-Germers experiment we discussed in the previous section. Okay, so those electrons that come out will actually pass through this accelerating anode. So this accelerating anode serves to speed up the electrons so that when they pass through this accelerating anode, they'll be at a greater speed right now. So electron was initially very slow or nearly at rest, but after it passed through the accelerating anode, by attracting them passing through this anode over here, you are speeding them up, so the electron will reach this part with a greater speed. Okay, then afterwards you are, okay, why am I not following this instruction here? Okay, so electrons are accelerated by a potential difference. Typically it's 40 to 400 kilovolt. So you're applying a potential difference of about 400 kilovolt over here. So a 400 kilovolt potential difference, you can put this place to be positive electrode, then this place to be a negative electrode. So the positive electrode will attract the electrons over, so the electron will speed up moving towards the accelerating anode, then you pass through the accelerating anode with a greater speed. Afterwards, the electrons are focused into a parallel beam, and this is the purpose of putting this condensing lens over here. So when they pass through the anode, the electrons might be moving in very spread out direction. The electron might be spraying out, something like that, when it comes out from the accelerating anode. So the condensing lens will serve to move those spraying out electrons, to be directing them to be moving downwards in a parallel beam. So all the electrons are moving in the same direction, pointing downwards. Okay, so those electrons will then pass through a specimen. Once they pass through a condensing lens, they will reach the object, then they will pass through a specimen. So when you have electrons pass through the specimen, you interact with the specimen, just like how light pass through your specimen. And then you have dark spots, you have brighter spots, and then you can create your image, right? When you have electron passing through your specimen, the amplitude of the electron wave will change, or the phase of the electron wave will change. So those kind of things will contain the information of the object, which will be displayed as the image later. Okay. So the electrons, after they pass through the object, they will be bent by magnetic field in the objective lens to form an intermediate image. So the electron that pass through the object over here, they pass through this lens over here. So this lens here has an opening in which you place a magnetic field inside here. So the magnetic field will serve to direct the electrons to move in a way that it can form an intermediate image somewhere over here. Then after that, the electrons will continue its journey downwards. They will be bent again by a magnetic field in the projection lens. And now after it passed through the projection lens, being directed by the magnetic field inside this projection lens, the electrons that come out will be incident onto a piece of image detector over here. So image detector, there's many types of image detector. You can put a scintillator over there. Scintillator is something that can detect electrons, or you can put some kind of sensor over there. So from there, you're able to form this kind of image in your computer. Okay, usually this kind of image detector is not something like an X-ray. X-ray, usually you pass through X-ray, then you can take the film and you can go and read it immediately. But usually for this kind of electron microscope, there's a kind of detector which is connected to a computer. Then from there, they are able to generate the image. So transmission electron microscope is usually used in the biological field, or actually in physics or chemistry field. They are used quite often also. But the general idea of why you use this kind of electron microscope is because you want to study something which is really, really tiny. Something that is even tiny, that is too tiny that light microscope is not able to observe clearly. So this kind of electron microscope definitely has a certain advantage, which we will discuss in the next video, and those advantage allows this electron microscope to be able to generate very clear image of very, very tiny object. So their magnification properties and they have high resolution. A combination of these factors causes us to be favoring electron microscope to study very, very tiny objects compared to light microscope.